Okay, well, good morning, everyone. Thank you for joining me today. Um, Let me move this around a little bit. My name is Phan Tran. I teach at Lake Washington Institute of Technology at a school that's across the lake from Seattle in a small town called Kirkland, if you know the area. I run the makerspace at our school called the I3 Innovation Lab, which stands for Imagine, Invent, and Inspire. And today I'm going to talk about 3D printing, design thinking, and the entrepreneurial mindset, and what I think that means for students. Um, so, as educators, we often talk about outcomes and goals for ourselves, for our students, for the institution. So for me, the question I ask is, what are the outcomes I'm looking for my students? This school started in 1949, and it had its foundation as actually an extension of high school and as a vocational VOTech. Eventually, it evolved, and today we're a college that actually offers eight bachelor's degrees. But the DNA is still very workforce centric. But in today's world, as you can see, our technology is changing so fast that I think that it's more than just training a student for a job. So some of the things I'm looking for my students is I want to create students that will be lifelong learners. They're going to see technology change, and they're going to have to keep on top of that. I want them to be creative problem solvers. I want them to break through silos, and that's education speak. Obviously, we know what that means. But for them, it means that they need to learn to be able to work across disciplines, people from different backgrounds, different training. And with design thinking, I want students to be action-oriented, and I want these students to be able to seek and recognize opportunity that comes up in the world. So with 3D printing, I'm sure we all remember that a couple years ago there was a lot of hype about 3D printers, and for some of us, because we deal with 3D printing every day, we can get a little jaded sometimes and maybe forget the magic involved with actually creating an object that initially was just in our mind. And I can recall the days when I was younger and I would have an idea and say, I wish I could make this idea happen. But unless you were a skilled woodworker or a machinist or welder and you had all the equipment, there was a pretty big barrier to entry. So if you recall, a couple years ago, we couldn't get by a day without reading an article about how amazing 3D printers were, and that they were going to bring about the fourth industrial revolution, that they were going to solve all the world's problems. It got a little ridiculous sometimes. And so when people realized it wasn't going to bring about world peace on top of manufacturing or fix all of your in-law problems, people realized it wasn't going to change that quickly. So we hit the trough of disillusionment. And as you can see, we have real life examples, right? We have 3D Systems and Stratasys, the major 3D companies, 3D printing companies of their day. And they, as you can see, January 13 to 14, there was a lot of media hype. And then when we realized that, when investors realized that they weren't going to sell that many printers, that the process of this change isn't going to happen overnight, they also, their stocks also went down. So that was a real life correlation to that graph, that hype graph. And at the time, Kickstarter was just coming to its own. And if you recall, 3D printers were a big part of Kickstarter's success. And I don't know if you recall some of these printers, but the Buccaneer, about 2013, it was the highest, it raised the most money for 3D printers for that day. And about a year later, if you remember ever seeing this be advertised on your social media feeds, they raised almost $3 million. And the commonality between these two are they don't really exist anymore. they failed miserably, because what they were trying to do was they were trying to capitalize on the hype, and they thought they could sell these $200 to $400 printers, only to realize that it's really difficult to manufacture products, and it's really difficult to manufacture and compete when you're selling on low price points. So the only companies I off the top of my head that survived that, and I'm sure there's some more, but Formlabs did it, and PrinterBot. I believe Ultimaker might have had a Kickstarter. But again, if you look at their price points, they price themselves reasonably so that the companies could sustain themselves. So, and at the heights of the hype, if you allow me to say that, MakerBot was acquired for $400 million in 2013. And if you looked at the numbers, it was a ridiculous number, because at the time, MakerBot had only sold roughly 22,000 printers. And if you do the math for that, let's say even if the printers were 2,000 each, at most, they had grossed maybe 40 million. And a couple years later, as an understatement, there's this headline: Stratasys may have overpaid. And there's even a documentary that's very interesting. I hear some audio coming through. That's right. If you want savings on living rooms, bedrooms, dining rooms, or I believe if yeah, there you go. If you can mute it. So we hit the trough of disillusionment, and then I feel that we are on this what the Gartner group is the one who actually came up with this graph, calls the slope of enlightenment, and the real world correlation to that is the fact that 3D printing now is being diffused out into a lot of different areas, not just the traditional garage tinkerers or just the purely prototyping manufacturers, but medical, prosthetics, automotive is a natural place. But it's really weaving its way into our society, and eventually we may get to a point where everyone may own a printer. But the articles that were coming out in 2013-14 made it feel like it was going to happen overnight. So the moment you purchase a 3D printer for your school, in effect, that room that 3D printer is sitting in becomes a makerspace. And if you just keep makerspaces as spaces where you make things, kind of craft things, that's interesting. But where makerspaces really become interesting is if you, there's a book called The Medici Effect. And the author for that is saying makerspaces, and if you can brand it and also bring this ethos to your school's culture, that makerspaces are not only spaces with machines and equipment that can help you fabricate things, but they're also places of intersection. So the Medici Effect, the book, the author believes that these places of intersection where you bring people of different backgrounds, and for my school, my goal for my makerspace is to bring students from engineering, from software development over, from the engineering graphics side, the guys who can do CAD, our electronic students, our machining students, to come together and then challenge each other with ideas and help each other. And when you have places of intersection like that, the Medici Effect, the author believes that you generate new ideas, and from those new ideas, hopefully innovation occurs. So when it comes back now, if we come back to concrete examples of how does an educator do this, I have two projects I give my digital fabrication students, and one of them is using 3D printing to solve a problem or fix something. So so I'm going to use a very mundane example of, let's say, the mundane example of, let's say, remote control. We've often, you might have lost the battery compartment cover for it. So on the micro level, that student essentially modeling a new cover, what typically would be an injected molded part, is okay. It's not particularly interesting, But on the macro level, the idea that the connection that that student has is there is a problem, and lo and behold, he or she is developing the design skills necessary to solve that problem. So on a micro level, it's a very mundane problem, but on the macro level, they're making connections about the power of creative design thinking that is more valuable. Another assignment I give is, and I'm stating it here in a very vague, ambiguous way, but creating an object that connects and or reconfigures another object, another material. So so I give them examples, and these are some examples. One, this is on the market, and what I'm trying to introduce here is I'm trying to introduce the idea of a whole genre of product and design, of accessories, of connector pieces, of designing something that they may have a specific solution for, but is open to be reinterpreted by the user to be used for all sorts of other things. And it also introduces the idea that, so on the micro level, it is essentially just connecting different components together. But on the macro level, what it's allowing them to connect is, here is a design challenge. They're going to create an object or product that solves their problem, but is open enough to potentially solve all sorts of other people's challenges, and challenges they've never imagined, which means, it also means that they're creating a solution for other people, and entrepreneurial thinking can come into play. And maybe they create something that in the future, if they're interested in, they want to monetize. So this is a nice example. 2x4 Basics makes these connector pieces for 2x4 wood. So these are other examples I show them that come from the web. Designers creating these 3D printed components to connect and make objects, in this case a coat rack. And in this case, this is what I'm going after. I want them to create kind of somewhat universal type joints that they can use. And so they may have an idea of what to make with it, but their end user, in this case, there are 2 different designs, but one, they made a desk with it. Another one, they made a cabinet with it. And so here's some more examples I show them from the internet. And so the 3D printing is useful to a tool, but it's through design thinking that allows them to take a design challenge and actually do something interesting with it. So when it comes to design thinking, the design thinking process, all design thinking processes can be categorized into fact-finding stages, idea finding, and solution finding. And the process, if we want to expand it, push Osborne and Parnes, you can see in the fact-finding stage, you want to define the problem. You do preparation, which means you do research. Maybe you talk to your end user, you observe, and then in the idea-finding process, you can use all different sorts of techniques of brainstorming, word association, picture associations. There's all sorts of different methodologies for ideation. And then you develop those better ideas, and you start culling the ideas down a little bit. And then solution finding is when you kind of do rapid prototyping. So David and Tom Kelly of IDEO, they're one of the top design firms, not only in this country, in the world, but they have a 6-step human-centered design process that also fits the framework of fact-finding, idea-finding, and solution finding. So they have observation, ideation, rapid prototyping, user feedback, iteration, and implementation. And any time in this process, they can always loop. They can always loop back. And so some of the benefits of design thinking is that it creates a framework for innovative problem solving. Because often, if you think about it, if you think of the 3 stages that I listed, at least in the most general sense, when a lot of people come up with ideas, they often jump to the idea formulation stage, or they jump automatically to the solution stage. So they bypass some stages that could be really useful in the process. And David Kelly, in his Creative Confidence book, because there's a methodology, because there's a framework, it reinforces the idea that anyone can be creative. It's not just artists, but obviously, and we know that engineers are creative. We know that machinists are creative, but this reinforces and reminds them that they have the ability to be very creative problem solvers. And David Kelly states, inherent in design thinking is an orientation towards action. And because of this action and problem solving, it's naturally entrepreneurial. So now the entrepreneurial mindset, what does that mean to me? So for me, the entrepreneurial mindset isn't just about monetizing an idea. It's more about the approaching the world in the sense of seeing challenges in the world and getting excited about those challenges because you're going to solve those challenges, whether it be a product or it could be a service, it could be a process. So that's where it's interesting to me. And because I think the world and the technology is moving so quickly, we have to help train and educate a whole generation that are going to see technology change very quickly. In their lifetime, they're going to see it change much more quickly than in my lifetime, in our lifetime. So I'm sure some of you have seen these articles. And okay, so we'll remind ourselves here that in the hype cycle, we have we obviously AI, machine learning, software development is kind of being hyped right now, and robotics, but it does point to something that I do think will really affect our young students. I have students who are 18, 20, so they're going to be in the workforce and they're going to be in the world actively engaged for the next 40 to 50 years. And so they're going to witness these things come true. So in the hype cycle, yeah, I probably do believe it's going to happen a lot more slowly than these articles are saying. And I want to include that there are differing opinions of it too, right? There will be opportunities created with AI and robotics and software. But one thing we can control as educators is this: we can change and evolve the way we educate this current generation. So let me just read this to you. I know we should read presentations, but let me read this. Instead of worrying about the mass unemployment robot Armageddon could bring, we should instead shift our attention to make sure workers, particularly low-wage workers, have the skills they need to compete in an automated era, says Jane Besson, an economist, Boston University law lecturer, author of the book Learning by Doing: The Real Connection Between Innovation, Wages, and Wealth. So the quote, "The problem is people are losing jobs and we're not doing a good job of giving them the skills and knowledge they need to work for the new jobs." So that circles back to the entrepreneurial mindset. So just to conclude and bring everything back together, 3D printing and by extension makerspaces are places of intersection for project-based collaboration, learning, and innovation. And for some campuses that are set up to be so, your makerspaces can become incubators for real products and ideas. Or if you have other departments, design thinking can even be used for social projects and process projects. So design thinking as a framework for creative problem solving. So what we're trying to attempt here is to teach a methodology that can be followed with discipline. There are no guarantees in design thinking. It still is going to be up to the tastes and the self-reflection of the team of designers. But as a methodology, it takes us just that much further than just randomly attacking a problem. And in today's in the future world, I really do believe that an entrepreneurship or an entrepreneurial, might I say, mindset is what is going to be necessary to meet the challenges of the future. So I just want to thank the folks at my school, my Vice President, Susie Ames, and my Dean, Mike Potter, who have been very supportive of myself and of the Innovation Lab. I also want to thank Mel Cosette and Robin Ballard for putting me in touch with Dr. Fidan at a really great additive manufacturing workshop that I attended this summer. And of course, Dr. Fidan and his colleague Terry Guo for helping me set this up. So I'm open to any questions.